In the last video, we talked about C++ as well as installed an IDE and the C++ compiler and explained the basic C++ starter code. Today we'll discuss data types and variables in C++. To understand variables in C++ or in programming in general, think of it as a box that stores one thing. In programming, a variable stores data, and this data can be of any type. Now, that was a simple explanation, but here's a more deeper explanation. When you create a variable and store data inside it, you're indirectly allocating or creating space inside your memory. This memory location has an address name. So to refer to data inside that address, you need to know the address, which is not efficient to memorize memory addresses. This is why variables have much simpler names which the programmer gives it, and you can call this variable by its name to get the data inside the memory. Now, what kind of data you can store inside a variable and how many space do these data takes inside the memory? So now we're in VS Code and let us learn how to create a variable. So to create a variable, we first need to specify, first of all, this is called a comment. It is not read by the C++ compiler. This is just used for the developer himself, okay? So how to create a variable? First of all, you need to specify the type of data. So type of data. Then after this, you need to specify the name of the variable. Let's say var name, and then use the equal sign, which will explain it later, and assign some data, okay? And making sure we put a semicolon at the end, because every statement in C++ ends with semicolon. Now let's create a real variable. So let's go down here and create a number, or a variable that stores a number. Like, for example, 12. Now 12 is an integer. So to create an integer, we first start by defining the type of variable, which will be int for integer, then the name of the variable called num1 for example, and use the equal operator and assign the number 12. So what happened here exactly is that we created a variable called num1 of type integer, and we've used the assignment operator, which is the equal sign in here, to assign the number 12 to the variable called num1. Let's do this again. So if I go ahead and say int num2 equal to 13, what I just did here is that I created a variable called num2 of type integer and assigned to it using the assignment operator the value of 13. Great, now we know how to create an integer. And by the way, integers can be positive or negative, so I could go ahead and say right here minus 12. But integers cannot be 12.2 for example. We'll see this type later on. But there's another type of integer you need to know about, and it is called short. So if I go ahead and say short, let's say short1 equal to 1 for example. Now this still stores a number, but what's the difference between short and integer? Well, basically short is smaller than integer. So both can store integers or numbers, but each one has a different maximum value, and of course integer is bigger than short. Now most of the case you will be using integer. You'll be declaring integers, not shorts. Now, of course, there's another type of integer or numbers you can say. Well, it's called long. And long is, of course, bigger than short, as well as bigger than integer. So you could declare a variable called long, let's say long1, and assign to it 1, 2, 3, for example. So long is, of course, bigger than integer, as well as bigger than short, and it takes much more memory than the other two, okay? But again, you should know them as a C++ developer, but you'll be using most of the time integer. Now that we know how to create numbers, but before we move further, I want to tell you that you can display these numbers in the console. So let's say I'll say std cout, and we know cout is used to output something on the screen, and we've used this insertion operator, it is called insertion operator, to be able to, well, display a message on the console. So I could say right here, I could say inside double quotations, and we will see what double quotation means further in this video. And so I will say something like num1 equal to, and I could use another time the insertion operator and mention my variable name. Okay, so the insertion operator can be used multiple times in the same cout to be able to, for example, display a long message like what I'm doing right here, num1 and then the variable name. And when you mention the variable name right here, it will give you the value. And let us test it. So if I go ahead and click on run, and where is it? There it is. So I don't know why this is here, but anyways, num1 equal to 12, okay? So when you mention the variable name, it will return for you the value that it stores. So now we know how to create numbers that are whole numbers, as well as how to display numbers or how to use variables and display them on the console. Now let me delete this cout right here and let us discover another type of data. So the other type of data I want you to know about is double. And let's just create a double. So double, let's say double 1 equal to 12.1. Now you can guess that double actually allows us to store inside a variable values that have decimal point, like 12.1 or for example 3.14. Okay? So we can store inside a variable decimal values. Unlike integers, they can be positive or negative values without decimal point. However, with double, they can be positive or negative values that have decimal point. Now, other than double, there is something called float. And float, let's say float 1 equal to 12 or 12.2, okay? So what's the difference between float and double? So both are data types that allows developers to use decimal points or numbers with decimal points. But float is smaller than double, and that means double takes more memory inside your memory, of course, but you'll be using most of the time double, okay? So now in C++ or in any programming language, we have something called Booleans. And Booleans can be only true or false. Let us see it. So I could first of all declare a variable of type bool, which stands for Boolean. I could say is true equal to true. And I could create bool, another variable, which its name is false and stores the value of false. So Booleans are only true or false. Now true stands for 1 and false stands for 0, okay? Now what happens if I go ahead and display those in the console? Let me go ahead and display is true, for example. So I will go ahead and say is true and let me run this. So actually I zoomed out the screen. As you can see, there is 1 right here. So true stands for 1. Let me change is true to is false. So if I say is false right here, it is the variable that stores the false Boolean data type. And so there it is. This is 0. 0 stands for false. Now let me zoom the screen again. Okay. And now how can we display, for example, on the console, instead of displaying 0 for false or 1 for true, how could we display true and false instead of 0 and 1? Well, we could use something called Boolalpha. So right before mentioning the Boolean variable, we could use something called Boolalpha. Okay, and right here. So this property right here, or functionality, allows us to transform 1 or 0 to the respective value, 1 to true and 0 to false. So let's go ahead and run this and see if it works. So I'm saying here is false, that should give me false. Now as you can see, 0 was transformed into false. So remember, without Boolalpha, if we want to display a Boolean, it will give us either a 0 for false or 1 for true. But now, because we used Boolalpha, it will give us the respective value if you want. So 1, it will give us true, and false, or 0, excuse me, will give us false, as you can see right here. Now that we know about Booleans and numbers as well as decimal numbers, let's go ahead and get to know another data type called char. Now char stands for character. So if I go ahead and declare a char variable right here and say char1, we should use single quotation to reference a char. And a char could be only a single letter, like the letter A, for example. So a char can be referenced by using single quotation, excuse me, as well as it should be only one letter. Now what if you want to store inside a variable your name? You cannot do this inside a char, because a char should only be a single letter. However, a name or a sentence is more than just one letter, right? So what to do here? We need to use something called a string, a data type called string. Now to do this, we need to mention the standard library or std, just like what we do with cout, and use string to declare a string data type or string variable. So let's call this name, and it will store the name John, for example. Now notice we use double quotations. That's because for a string, you reference it using a double quotation or double quotations. However, with a char, you use only single quotations. And of course, so what we did here is we declared a variable called name of type string, and we assigned to it the value or text John, or the name John. Now again, you can go ahead and display the name. So let's say my name equal to, and I'll say right here name, which is the variable name, and it should return for me John. And it's somewhere right here. I don't know what's happening today on my console. It's just displaying this right here. Let me run this again, and hopefully we'll get it in a better position. As you can see here, my name equals John. Let me zoom out. There it is. My name equals John. Okay. So these are the data types that you should know. There's other data types that we will cover in this course, but these are, for example, the primitive data types that you should know. Now you're noticing here that we are always using std and double points. Now this operator right here is called the scope resolution operator. We'll see it later on. But why are we each time using standard or std cout or std string each time? Well, let me tell you why. Basically, these components right here comes from the standard library. Okay, and if you want to use them in your code, you need to tell C++ that they come from this library and I want to use them. So cout comes from the standard library, as well as string comes from the standard library. That is why we should always use this std right here whenever we are using a component of the standard library. But we can get rid of this, and we could use the following notation. So right below include, you can say using namespace std. What this allows you to do, or what this does for you, is it won't anymore oblige you to use std and the scope resolution operator. So I could just go ahead and delete those, and boom, nothing happens. I won't get any errors. Of course, you could say something like here, instead of using namespace std, you could say using std string, for example. This will only allow you to take off the std from the string. But as you can see here on cout, I'm having an error because it cannot know, or the C++ is not knowing how to identify the cout, because cout comes from the standard library. But if I go ahead and say using std cout, as you can see, the error goes. Now, of course, it's better to stick to using namespace std, okay, but it's all your choice. Okay, great. Now there's something else I want to show you. Now if I go ahead and create another cout, and of course you can create multiple couts, and if I say something like my char equal to char1, for example, okay? Let me go ahead and run my code. Let me zoom out again. As you can see, my name is John and my char is A. Now there's nothing wrong with the output, but they are on the same line and I don't want that. I want my char equal to A to be on a new line. How to do that? So basically what we need to do is tell C++ to add a new line. So how to do this? Well, there's two ways. Let me show you the first way and the most common way. So after the name variable, or right here, we could re-mention the insertion operator and mention Endl. And again, Endl it's coming from the standard library. That means if you take off using namespace std, you should add std right here for the Endl, okay? That's just a side note. But Endl right here means that it's telling C++ to add a new line. And okay, good. Now it adds a new line. So Endl adds a new line. So instead of Endl, what I could do is use the escape sequence. So how to write this is that you should be inside a string and mention \n. \n, or n means a new line. Now be careful, it should always be inside double quotations or inside a string, okay? So that is why I re-mentioned the insertion operator and then define two quotations, and inside those two quotations \n will be placed. Now if I go ahead, run this code, we should get the same output. So as you can see right here, my name's John, new line, my char is A. Now in the beginning of this video, we said that data occupies certain space inside the memory based on their size. So we can find their size of each of these data types that we've learned today using a function called sizeOf. So this sizeOf function takes an argument or an input from the programmer, and this input should be a data type. So this is the sizeOf method, and inside the sizeOf method, it should take an input. Now when you see this notation, or like any notation that has a parenthesis right here, this means that it is a function. Like here, in the main function, this is called a function, as well as the size of, it is called also a function. Now inside those parentheses, size of takes a data type, okay? So you give size of a data type, so you're asking basically size of to give you the size of this data. So if you ask size of to give you the size of an integer, it will return for you the size of an integer. Now, how do we tell size of to do this? Well, you need to call size of, okay? So when you call size of, you need to mention an argument or an input for size of. Let us say int. And when you say int, it means an integer, like 12 or minus 12. So we're asking size of what is the size of an integer. Well, of course, we could go ahead and print this on the console. So I could say size of integer equal to and size of. Make sure to add here Endl. Okay? Now let us see what will size of give us. Now as you can see, size of integer or an integer number is 4. Well, 4 bytes. Well, we could go ahead and display it right here. So after this, we could go ahead and say 4 bytes. Yes, this is more comprehensive. So the size of an integer is 4 bytes. Now we said short numbers or the short data type is smaller than an integer. Let us see. So if I go ahead here and say short, so we are basically finding the size of a short integer, or excuse me, short number. So size of short, well, short is a data type. Let us see what is the size of short. So short has 2 bytes, while integer has 4 bytes, okay? Now we could do the same thing for the other data types. And so I'm going to write them all right here. Okay, good. Now let us go ahead and display the size of short, integer, long, float, double, boolean, char, and string, okay? Let's go ahead, run this code, and let us see what we will get. So look at this. Short is 2 bytes, integer is 4 byte. Now long is mentioned here as 4 byte, but remember long is bigger than integer, okay? Now floating point numbers are of 4 bytes, but doubles are of 8 bytes. So when you declare, for example, a double, it occupies 8 bytes inside the memory. However, if you declare a floating point number, or excuse me, a decimal number of type float, that means it will take 4 bytes inside this memory, or your memory. However, you can see that size of boolean is only 1 byte. So when you declare a boolean, it will only take 1 byte inside your memory. And then we get strings, it will take 32 bytes. Well, strings is the biggest for now. Okay, so this is how you can find the size of each of these data types. And of course, remember those sizes, you should not remember them because you can go ahead and display them, but it's good to know. And this is it for this video. We've learned how to declare variables, we've learned about different data types, we've learned about the size of function, Boolalpha, and how to define a new line in Cout. And in the next video, we will learn about how to use arithmetic operators as well as global and local scope in C++. So stay tuned for the next video. And now I invite you to watch one of these end screens that will appear right now, and make sure to subscribe and follow me in the C++ tutorial series. And I hope to see you in the next video.